Welcome to Geometry. I hope you are well. This is our first day of new notes since the shutdown. The fill in the blank notes page is on my Google site, so if you don't have that printed, you can download it, pause this, download it, and get it printed out for you to fill in. If you don't have a printer with ink or you can't find it, you can always use a regular piece of paper and do the notes on normal paper, pausing the video so that you have time to draw in some of the pictures that are on the fill in the blank notes. This day of notes, 8.4 special right triangles, accompanies the 8.4 special right triangle ratios homework. There's one packet for days 1 and 2, both. So we do odds and evens on that, and that will also be uploaded to my Google site. If you remember, before we left on the break, we spent some time on similar triangles. And one of the things that we learned about similar triangles was that the sides are always going to be proportional. So if you have a small triangle, like this one, a similar triangle will have the exact same angles. So these two will match, these two will match, these two will match, but the sides are going to be a multiple of the smallest triangle side length. So remember the magic multiplier. If we know that this side length is 3 and this one is 6, because 3 times 2 equals 6, we know that the magic multiplier is 2. Now if you remember, we took the sides of one triangle and we put them into a colon format. So 3, 3, 4. Once we figured out the magic multiplier, which was either from that we're being given or we calculated it from a pair of matching sides. So in this case, 3 and 6 matched up. 3 times my magic multiplier is 6, and we apply the same magic multiplier to the other sides. 3 times m will be 6 for the other side length on the triangle. 4 times m is 2, so 4 times m will be 8. So the bottom length will be 8. So these were similar triangles. We made the sides into a ratio and figured out the magic multiplier to get missing side lengths. So the new material in 8.4 is actually very close to this. The difference is we're going to start to recognize some very special right triangles. These are triangles that come up more often in science and in math than the others. And there's 2 special right triangles we learned, a 45-45-90 triangle and a 30-60-90. So for Roman numeral 1, theorem 8.6, we're going to do the 45-45-90 triangle theorem. This says in a 45-45-90 triangle, the length of the hypotenuse is the square root of 2. So in the smallest 45-45-90 triangle, the hypotenuse C is square root 2, and sides A and B, which are the same length, are both 1s. So putting our side lengths into a colon form, we have length 1, and length radical 2. Now we can find the lengths of any other sides of a 45-45 if we have a matching pair of sides or if we're given the magic multiplier. Well, let's do the example. Let's say that on our new triangle, A is 13 inches. So A is one of the small sides, so we put the 13 inches across from here. And obviously, since A and B are the same, if A is 13, then B must also be 13. Now, to find C, we need to find the magic multiplier. Well, here's our match pair. 1 times m is 13. Sometimes you have to come out and actually solve that. Sometimes you can do it in your head. 1 times m equals 13, so my magic multiplier is 13. That means I can take my square root of 2, multiply it by the magic multiplier, and get the side length. Well, radical 2 times 13 is 13 radical 2. That is our side length C. So that's an example of a problem where you're going to use the base side lengths of a 45-45, which is here, to find missing lengths of any other similar triangles. Okay, let's do another one of these. Example 2, find the value of x. All right, because this is a right triangle and two sides are the same, it automatically means it has to be a 45-45, 90. That's because this box says that that angle is 90, which means these two angles split the other 90 in half. One of them is 45 degrees, the other one is 45 degrees. So yes, this is a 45-45, 90. So let's start by writing that down. 45, 45, 90. And the side opposite the 45 is x. But before we write that, we're going to write down the side ratio. Every 45-45, 90 triangle has sides in the ratio 1, 1, radical 2. In this triangle, x is our opposite the 45s, and a 6 is opposite the 90. So our pair of side lengths to get the magic multiplier is radical 2 and 6. So this is one where you're going to want to actually solve for m rather than try to do it in your head. So radical 2 times m is 6. Multiply both sides by 1 over radical 2. M is 6 over radical 2. Rationalize, so we have to multiply the bottom and the top by a radical 2 to get rid of the radical in the bottom. So on the top, 6 is a scalar, so 6 radical 2. On the bottom, 2 2's, 1 comes out. Your last move is to divide a 2 out of the scalars. That will give us 3 radical 2 as our magic multiplier. So to find x, we multiply 1 times our magic multiplier, which is 3 radical 2. So x must be 3 radical 2. So again, to recap, we used the two side lengths that we had, one from the theorem and one from the picture. We used that matching pair to get the magic multiplier. We used that to find x. All right, let's do example 3. Okay, in this triangle, again, we have a right triangle with two congruent legs. So that means that the angles opposite the congruent legs are also congruent. So they have to be 45s. Because the legs are congruent, if this leg is 6 radical 2, this other leg is also 6 radical 2. And we're supposed to find the value of x. All right, so let's start by writing the type of triangle. This is a 45-45, 90. The ratio of the sides of all 45-45, 90 triangles is 1, 1, radical 2. Filling in what I have, the side opposite the 45 degrees is 6 radical 2. So those will both be 6 radical 2. And I'm looking for the hypotenuse, which is opposite the 90. That's my x. All right, now that we've got this lined up, we need to find the magic multiplier. 1 times m, the magic multiplier is 6 radical 2, which means the magic multiplier must be 6 radical 2. You can pretty much do that one in your head. So now to find x, we're going to multiply radical 2 by the magic multiplier and set it equal to x. So radical 2 times 6 radical 2 is equal to x. 2 2's, 1 comes out. I have 6 times 2 is x, so x must be 12. This format of setting up the equation is one you're going to use a lot, and it's pretty straightforward. All right, let's do a couple more practice problems. Given the following triangle RST, find the missing values. All right, this is a 90-degree triangle with a 45-degree acute angle. That means this one has to be 45 degrees. And for the first one, now remember that lowercase r means it's opposite uppercase R. So if this is angle capital R, this is side lowercase r. If this is angle capital T, this is lowercase t. And if this other angle is a capital S, the side opposite is a lowercase s. These always match up that way. All right, it says, what if R is 6? Find T. Okay, here we go. So we have a 45, 45, 90-degree triangle whose sides are always in the ratio 1, 1, radical 2. Opposite the 45 is R, so our 6 will go opposite the 45, a 6 will go opposite the other one, and we're trying to find T, which is opposite the 90. So now we need to find the magic multiplier. Here's our matching pair. 1 times m is 6, which means m has to be 6. So magic multiplier is 6. So taking that, radical 2 times m is t. So t is 6 radical 2. All right, let's do another one. If lowercase s, that's this side, is 2 radical 5, what is t? So again, we have a 45, 45, 90 triangle whose sides reduce to 1, 1, radical 2. We're told that s is 2 radical 5, which means anything opposite the 45 is 2 radical 5. So write in 2 radical 5, another 2 radical 5, and we're looking for lowercase t, which is opposite the 90 degrees. All right, 1 times my magic multiplier is 2 radical 5. So obviously my magic multiplier is 2 radical 5. This is another one you can do in your head. So now we're going to take radical 2 times my m. That gives me t. So radical 2 times 2 radical 5. Scalars first. Scalar 1 times scalar 2 is 2. And then now the radicands. I have a 2 and a 5. They multiply to give me 10. All right, last one of these, and then we're going to move on to our second triangle. So if t is radical 2, so if the hypotenuse is radical 2, we're trying to find r. Again, this is a 45, 45, 90 triangle whose sides reduce to 1, 1, radical 2. T is opposite the 90. That is radical 2. R is opposite the 45. We can use that one for R. All right, radical 2 times our magic multiplier gave us a radical 2. That means your magic multiplier must have been a 1, which makes this a very easy problem because 1 times m is r, 1 times 1 is 1. R has to be 1. All right, so those are our 45, 45, 90 triangles. Flip over your notes page. The second special triangle that we learned, there's only two, is a 30, 60, 90 triangle. And the best part about this is that the process is practically identical to how we did the 45, 45. The only difference is the ratio of the sides. And in a 30, 60, 90, you're going to have 3 different angles, which means 3 different sides. So, Theorem 8.7, given a 30, 60, 90 right triangle, obviously, leg A, lowercase a, in this picture is opposite the 30-degree angle. The longer leg B is opposite the 60-degree angle. And of course, hypotenuse C is opposite the 90-degree angle. The actual theorem says the hypotenuse is twice as long as the short leg. So C, which is the hypotenuse, equals 2 times leg A. And the longer leg is radical 3 times as long as the short leg. So B equals radical 3 times A. Now, of course, that's the theorem. It's much easier, I think, if you set it up as in colon form, 30, 60, 90, and the sides are always going to be 1 opposite the 30, radical 3 opposite the 60, and 2 opposite the 90. There is your ratio of sides. So again, the short leg is 1, the long leg is radical 3, the hypotenuse is 2, and that's as small as that triangle can get. All right, example 1. Given a right triangle, if the side opposite the 30-degree angle is 4 feet, what are the lengths of the other two sides? Now, rather than use the long method with the theorem, we're just going to use a triangle ratio. It's actually a lot faster. So this is a 30, 60, 90 triangle whose side lengths will always reduce to 1, radical 3, and 2. Now, in the case of this problem, the side opposite the 30 degrees is 4 feet. I do not have the side opposite the 60 or the 90. I'm trying to find those. So let's call the side opposite the 60 lowercase b and the side opposite the 90 lowercase c. So all we need to do is find the magic multiplier and multiply the reduced sides by that number to get these sides. Well, here's our pair. 1 times m is 4, so the magic multiplier must be 4. Now we can find the other sides. Radical 3 times 4 is our b value, so b must be 4 radical 3. There's one of your answers. 2 times the magic multiplier is c, so 2 times 4 is 8. C equals 8, and we have done the problem. Pretty straightforward. All right, let's do example 2. Find the values of x and y. Now, they're not always going to tell you you have a 60 and a 30, but if you have a 90-degree angle here, and all three of them have to add up to 180, if this one is 60, the only way it's going to add up to 180 is if this one is 30. So sometimes you will have to fill those in. And we're trying to find x and y. Okay, so first thing we write down is the fact that we have a 30, 60, 90-degree triangle whose side lengths always reduce to 1, radical 3, and 2. On this triangle, the side opposite the 30 has a length of 5. The side opposite the 60 is x. The side opposite the 90 is y. And we need to figure out the magic multiplier to get from our side ratios to our new triangle. Here's our pair. 1 times m is 5. That means our magic multiplier is 5. Now we can calculate the other values. So radical 3 times my magic multiplier 5 is x. So x is 5 radical 3. Now the y. 2 times my magic multiplier, which is 5, equals y. So y is 10, and we have our sides. All right, so if you want to pause the video and try example 3 on your own and then start the video back up again to see if you're correct, that would be a good idea to make sure that you have this. So you may pause it, try it on your own, and then fix it as you go. All right, this is a 30, 60, 90 triangle. And for number 1, Q is 8. So here we go. 30, 60, 90-degree triangle. Side ratios reduced to 1, radical 3, and 2. Q is opposite the 30. And we know that Q is 8. We are looking for P, which is opposite the 60, and N, which is opposite the 90. All right, so we need to find our magic multiplier. Here's our pair. M times 1 is 8, so my magic multiplier is 8. So let's find the other two sides. P is radical 3 times the magic multiplier, so 8 radical 3. N is 2 times the magic multiplier. 2 times 8 is 16. All right, in B, we're given the hypotenuse. So again, we have a 30, 60, 90-degree triangle whose sides reduce to 1, radical 3, and 2. They've given you 20 for N. N is opposite the 90. We're looking for the other two sides. Okay, so Q is opposite the 30. P is opposite the 60. All right, looking for the pair that will give us the magic multiplier. They told you P is 9. Oops, I didn't write that in there. So that is going to be our pair. This one you might want to calculate on the side. Radical 3 times m equals 9. So we multiply by 1 over radical 3 on both sides. M equals 9 over radical 3. Rationalize. You know, I think I just moved on to number 3. I'm sorry, I skipped problems on you. Not fair. This is actually problem C here, where P is actually 9. All right, so we're going to finish this one. This is C. So square root 3. The magic multiplier is 9 square root 3 over 3, which reduces to 3 radical 3. So if P is 9, then Q is 1 times the magic multiplier, so 3 radical 3. N is 2 times the magic multiplier, so 6 radical 3. All right, let's go back then and do B. Sorry about skipping. So we have a 30, 60, 90 triangle whose sides reduce to 1, radical 3, and 2. N is opposite the 90, so 20 goes here. And we're looking for Q and P. Q is across from the 30, P is across from the 60. Okay, magic multiplier. Here's our pair. 2 times m is 20, so magic multiplier must be 10. That's a nice number. So 1 times m is Q, so Q must be 10. Radical 3 times m is P, so P must be 10 radical 3. I hope that this lesson made sense to you. If it doesn't, I'd recommend rewinding and playing it again. Have a good afternoon.